Okay, there you go. Um, so in this class, we're gonna explore a few tools on Fusion 360. Um, the idea for us today is that we're gonna build a pen shell that has hexagon patterns as extrusions and tapered angles going inside the cylinder that we're gonna build here. Okay. Um, since we're gonna use it, we're gonna make that process as an extrusion and not as an emboss, how we usually made. It's not it's not really easy for us to just calculate it. So we're gonna have to eyeball some of the things here that we're building. Um, my suggestion for you is that you maybe if you're trying to build something and you want to have like 100% precision, like 100% symmetric, you go for ChatGPT and you ask you give up like or you give like the operations that you're trying to build like oh say it's a extrusion with taper so the extrusion will be in a tangency of the cylinder and then we're gonna extrude going in the outside radius is X, the inner radius is W and all of that, so yeah. um, let's do the following. So we start our project here. um, I'm gonna first do a home here. I can see my camera is inverted. Um, we're gonna go for create and create sketch. For more that you feel tempted to build a cylinder to just build that, I recommend you doing a sketch instead. And always select the bottom sketch. You're gonna see that it's selected correctly because it's gonna say top in here. So we're looking from the top perspective. Um, we're gonna press C for circle, and we going for the orange in here. You can see that your mouse will lock in position. We're clicking ons in the middle, and then and we move our mouse outside, and then it's gonna ask us for a diameter for a circle. So let's go for D. Sorry, not for D. We're gonna type down 19 millimeters here. Okay, and there you go. We have our um, diameter already defined. Okay, and now we're gonna open an extrusion by pressing E, and you can see that it automatically selects for us our extrusion face here, because that's the only face available. So I'm gonna define that as 8-inch int. So yeah, there you go. Now it's 8 inches. So as you can see, you can convert automatically from um, inches to from inches to millimeters. You just need to specify, oh, it's 8 millimeters. Okay, do is 8. I'm gonna actually define as 8 inches. You just define in, or you do the 7 8 quote like that, like double quote. Sorry. You make the double quotes. Yeah. I'm happy with that measure. Let's keep working with that. The first thing that we're gonna do here is we're gonna go for construct. We're gonna go for tangent plane, and we are selecting the outer wall of our cylinder here. And as you can see, it creates for us on the perfect tangency of our cylinder the construction plane. For more that it may look kind of off for you, it's just a rendering bug. It is perfectly on the tangency of that body there. Okay. Um, one second. So taking that in consideration, we're gonna open a sketch over this face here. So let's go for create sketch. And now we have a sketch open on the perfect tangency of our cylinder here. So I'm gonna zoom in the oranging, which is where we have this black dot here. And the first thing that we're gonna do is we're gonna set up some measures in here. We're gonna go for construction. So we press L and go for construction in the right here. We have line open right now. You can see by my mouse that we have a tool attached to it. I'm going for the oranging. Going up, I do 1 millimeter distance because that's the spacing I'm looking for. I'm going to build another line as L, keep the construction on. We're gonna define it in a. We're not gonna specify a number. We're just clicking in the start point, which is in the end of the first line we just draw, and we're going up and clicking in a random measure. Okay, let's do okay. Now, what we need to do is we're gonna go for the middle of this line, and you can see that's the middle of the line because the line starts here and ends here. So if I move closer to the middle, it will lock for me here. So that's the middle point. I'm gonna click here and go to the left. And here we're gonna define what is the radius of our hexagon, okay? I'm gonna click and do OK. And I forgot to define the dimension, that's not a problem. I'm just gonna do D on my keyboard, click on the line, move up, define, and we're gonna define that as 2.8 millimeters. That's the radius of my hexagon that I'm building. So now I can disable the construction mode. I can go for create, I can go for polygon, circumscribed polygon. I click on the center of my body in here, and then if I move my mouse to the end of the line we just built, you can see that it's gonna be perfectly symmetric. And the reason why we did all of that instead of just going for the middle here and building anywhere is because, for example, if we build it down, can you see the position in which the side corners are touching? And usually it can cause us more problems, especially during the aligning process. Okay, so we're gonna keep them like that. Okay, we're gonna keep them just like that with the corners horizontal. Okay, so all we need to do now is make this point touch this point here. We have a tool for that. It's called coincident. I'm gonna click on the end of my hexagon and in the end of my line, and as you can see here, um, it changes the size of our hexagon, right? What we need to do now is I'm gonna make this face touch. I still have the constant to open. This face touch, this face here. There we go. Now it's perfect. We have our 2.8 millimeters radius. We have the 1 millimeter spacing. We are pretty much good to go. I'm gonna do a right click on my sketch and show dimension. Just why not, right? Um, we are outside the sketch now. I'm gonna do an extrusion. And there's actually one process that I forgot here. We need to make this hollow, right? Let's go for shell on the modify section. We're gonna select the bottom and the top, and we're gonna define the shell thickness as 5 millimeters. Let's actually make it like 7 millimeters. No, too much. 6 is good. Okay, so there we go. We have now the extrusion hollow because we selected both faces, right? The bottom and the top one. And now we can go here for extrusion. We can extrude inside. And as we extrude inside, we need to change the taper angle. Let's make it -17, for example. Um, I think that's good. I think that's good. And we can see the cut here, but instead of doing a cut, we're gonna go for new body, okay? Of course, if you wanna make different numbers, you can. You may have to adjust it differently after, but that should not be a problem, okay? So first thing, let's go for pattern. Let's go for a circular pattern. We're selecting our objects. We're going for axis and selecting the edge here. I'm gonna see what I can do with 10 units of hexagons on here, okay? So it's quite hard to calculate the distance correctly from them because if we measure from here to here, we have a measure, but that's not very truthful because the the only right way of measuring would be from here to here. Okay, I'm gonna try something here. I'm not sure if it's gonna work, so that's gonna be a plus for the video. Like it's just something that I want to try. So if I go here for split face and select this face here, and as a splitting tool, I select the wall of the cylinder, click and do OK. There we go. Now we have a point on the tangency of my hexagon. Just to explain what I did, I basically cutted that face. That face was solid. It was only one face on the entire area. I asked Fusion to cut that face, building a line here for me. Uh, so I can measure straight from the 0 point of the radius to the next one. Let me repeat the same process from here. So let's go for modify. Let's go for a split face. I'm gonna select here, and I'm gonna select here my cylinder. So the first thing that I select is the face I want to cut, and the second thing I select is what I want to use as a cutting reference. You can see that when I select the water radius of the cylinder, it shows me what cut it's making, right? We can see this walls of the cylinder in red. So let's do OK. And if we hide here, we can see that face is splitting, and that face is also splitting. So now if we go for measure on the inspect section and we click here and here, we have the spacing of 0.531. Um, is that the correct way of measuring it? It depends a lot. There's no, it's gonna depend a lot on the way you're making it, because if you're making as an emboss, it's one way, it's a circumference, so you're gonna have to find a good way, or see if the ways I'm showing you are valid for what you're trying to measure here. Okay. I'm considering decreasing the number of them so I can have a better distance between them, at least from the way I'm measuring. So right now I have um, 1.2 millimeters. I want to solve that, but I want to solve that making my hexagon is slightly bigger. So I'm going to change it to 2.9 millimeters. And it's still symmetric, it's still centralized because we did everything right here. So yeah, let's finish the sketch. Let's go for inspect. Let me find my cutted face, this one. Inspect, so measure from here to here. We have exactly 1 millimeter, that's wonderful. So now let's go up. And now comes the tricky part, okay? Um, what we're gonna try here first, and you can, it's up to you if you wanna move up first and define the height already, or if you want to um, rotate it first. I wanna rotate it first, so I'm gonna select, so actually I'm gonna do a Ctrl Z, I'm gonna select all my bodies, except my first one. I'm gonna do a copy and paste. I'm gonna go for set pivot, select the edge of the cylinder, and confirm the set pivot. Now I want to rotate it first and try my best here to align this with the middle of those, okay? So the first challenge here is to actually have a good perspective on what you're doing. Um, right here, we have a slightly a point of reference, and I can see that it's too much for the right, so I'm going to change the number to 19, by example. It made it worse, so I need to increase. So let's go for 20.5. Okay, 20.1. Okay, so right now it looks very, very close for me. Um, I can imagine the middle line here, and you can see this is very good for me. So let's now move it up, and then we need to define what is the distancing that we want between them. I moved then 5.5 millimeters up. Um, I don't think that's enough. I think the space between here and here is bigger than the distance between the center point here. So I'm going to make it 6 millimeters going up. Now it's too much. So we know that the value is now between 5.5 and 6. So let's make 5.7. 5.7 looks very good. I can see a triangle, like a perfect triangle in here. That's exactly what we're looking for. So let's confirm our operation. Okay. Let's take a look around. Let's see. By looking from far, I believe we can move them slightly up, like just a little bit up, so we can have, let me see if there's nothing missing. Yeah, okay, there you go. I want to move them up by 0.1 millimeters. Let me see, 0.2. I think it looked better like this. 1.17. Okay. Um, I'm happy with that. We do have a way of verifying that if we go for construction and re-enable the tangency here, and we go for create sketch. We can do something very silly. We go for create and polygon and circumscribe it polygon, and then let's drag our reference point here. So we hover our mouse here, go up. My mouse is locked, and I'm gonna click, okay, close to the center here, and I'm gonna go down. Before clicking again, I'm pressing tab to change the quantity of corners on my hexagon to 3. Oh, I think I changed the wrong number. So I'm gonna press tab again and 3. Okay, so now let me press tab again and change the size. So as you can see, size we changed it to 3. We now have a triangle. Um, the way we gotta make it is let's try to align it like that, and let's make it smaller. Too small, getting closer. Okay. So here it's showing to us that we can use that as a reference at least. I'm gonna click. I'm gonna select both lines and press M, and let me move it up. Okay. So as you can see, we move the triangle up that much to go back. So as you can see here, it's slightly aligned. Actually, let's do the following. I'm gonna bring it down slightly. This is just a measure thing. That's not actually something you need to do if you don't want to. If you're not, because that's not visible by the eye. You see, but the heart of a good designer will feel that. So um, you can see it's aligned. It is aligning here. So, but it's not aligning here. So that number we don't worry much about that. We can actually do OK, and we select again the triangle and press M. So now everything is 0. We move up to the corners of the triangle touch. So now it gives us the number minus 0.05 millimeters. And taking that in consideration, we are selecting again all the top row hexagons, and we're moving that up by, it's not a negative number, since it's going up, 0.05 millimeters. There we go. We can see that we have a pretty good symmetry. It is not perfect. I can assure you that. It's if you measure it correctly, you're gonna find like uh, error of like 0.05 millimeters or 0.01 millimeters. So it's gonna be a very small variation. But for what we're looking here, and since we're doing extrusions and not emboss, I don't feel, as I showed you before, I don't feel there's a way for us to measure exactly um, the distance between them to make it 100% correct. So yeah, let's go for um, let's go for combine. In the modify section here, we have the combine. We select the first body, the body we want to modify, and the second body here, in the two bodies, click on select and go for cut. You select all your bodies, you hold shift and do a box selection. There you go. Not everything was selected. Let's go on the opposite side, hold shift and select, and let's do OK. All right, there we go. So now it looks very good. Let's reproduce it to the top. Okay, so let's go for create. Let's go for pattern. Let's go for rectangular pattern. And let's go for object type here. And let's change it to features. What we need to select is basically um, those operations here. So we're going to select all of that. And as axis, we're going to select the blue line here, or the z-axis. And here is where the good habits and organization comes handy, because right now we are using the origin our project that is always centralized in the workspace as reference for what we're building. It may be hard to see because of how polluted it is, but if I look like this, you're gonna be able to see that's the blue line I'm talking about. That's the z-axis, that's the axis, and that's the y-axis. Yeah. So now, taking that in consideration, let's move it up. Before worrying much about stuff, we need to make sure that it's actually working. So let's do OK. As you can see, it gave us uh, nothing as a result. Um, and if you have an error message, you won't have a register of the operation we just did on the timeline. Um, in here, I do have, but it did not work it. So the reason why we go for edit is we change compute to optimize it, for example. Okay, there we go. Optimize it worked very well, as you can see. Um, all we need to make sure now is the spacing. You can see the spacing here is not uneven. It's not the same as this spacing here. Okay. So what we're gonna do is we're gonna go back to the sketch. Sorry, we're gonna go back to the rectangular pattern on the timeline, and let's increase that distance slightly. Let's go for 23.2, and let's see what is the result. Still not really good. Let's bring it up slightly. There you go. It's more up. Now it looks very good. It looks very symmetric for me, very even. So that's the number that we have. The I am on extend mode, and I can use that number that I just came up with as 23.5 as a spacing distribution type. And then, as you can see, it automatically divided that distance for the number that we need. Okay, so the number before was 23.5, right? And if we divide that by 2, it will be the number that was before, which is, let me see, somewhere it will show, it's 17.25. Yeah, so now all we need to do is add quantity, and it will start building up. Not that much, like this is good. There we go. So here we have it perfectly symmetric. Um, this is a annoying operation because you cannot just like go point to point here. Um, because we're not working with the proper tools. That's the reason why. We should be using emboss, but embosses they don't do tapers, so we're working with what we have, and we actually managed to achieve a very good result with that. Okay, so I'm also gonna provide the file of that I just built here. If you wanna go back in the timeline, for example, if you positionate your camera here in home, you can do play in the bottom here, and it will show a timeline of everything that was done during the process here, like as a timeline process. There you go. Yep. So that's it for this class. I actually had to record this class like 4 times. So if I went too straight into some stuff, it's because I already did that same process 4 times. So yeah. Um, yeah, I think that's pretty much it. The areas that you most need to pay attention is the sketch 6 and the numbers here. Make sure that everything is constrained, that your hexagon is not um, tilted like to the sides. If you want to make sure that your hexagon is perfectly vertical, you can go for constraints here and select this wall or this one here, and it will lock your hexagon in position and won't make it rotate to the sides. It should not naturally rotate to the sides if you did exactly how I show it in here, but if that's the case, you just click here and constrain it. Okay. So yeah, that's pretty much it.